So this is LeetCode 938 range sum of binary search tree. So in your input, you're given a root, and you are supposed to traverse the whole tree and output a sum if the root values are in between a given low value and a high value. So for this example, you're outputting 32 because you're saying the low number is 7, the high number is 15. So if any one of these nodes are higher than or equal to 7 or lower than or equal to 15, you add them up. So that's adding up all of these except for 18, and that will give you, and it won't be 3 to either. So it's nodes 7, 10, and 15 added together are 32. Okay, so this is rated easy, and it is easy as long as you know how to traverse a binary search tree. So the first thing we could just do this is I'm just going to create a somewhat global variable so that I can keep it outside of this method, which this method is really just going to be a loop, and it's going to keep traversing. So it's going to have a different state than the outside state, which is just going to be the answer that I want to return, which is going to be just called answer, and I'm going to start it off at 0. So that's going to be here. And when you are writing a recursive function, you're just going to say check for my base case, which is root null. If it is, I'm going to return my answer. If not, and I'm going to do an in-order traversal. I'm going to say traverse left. I'm at the root. Check if root value is in right window or range. If yes, it is, add it to the sum. If not, continue. And then I'm going traverse right, traverse. And then after I'm done traversing, I'm going to return the answer. Okay. So here we are, and we're going to say if root is null. I'm just going to return the answer right now. And so the definition of root is this tree type right here. If it's not null, first I'm going to traverse left. So I'm going to just recursively call this. I'm going to say root left, and I'm going to send low and then high, background. And I'm going to check if root value is greater than or equal to the low value, and root value is less than or equal to the high value. This is something I want to add to the sum. Now I'm going to traverse right. And that's going to do all the work for me. And at the end, I can just return my answer. And let me run this. And that is right. Let me submit. And it has a pretty good, pretty fast memory. Runtime's a little, it's like 56th percentile, something like that. So it's a very short amount of code. that we can really just reuse this method here, as long as we can keep our answer out of, we don't have to write another method, as long as they are allowed to keep it over here. So if you could see, this is how, if you want to print, I'm going to print line root L. So if it's not known, we can just print it every time. Let's see what the case 1 shows us. So you could see it traverses the entire thing. It goes from 10 to 5 to 3 to 7 to 15 to 18. So 10 to 5 to 3 to 7 to 15 and 18, because it's doing an in-order traversal. You don't have to do an in-order traversal. You can do a pre-order or a post-order. It will work the same, and all that means is where you put this. Do you put this in the front? It's a pre-order. If you put it here, it's a pre-order traversal. If you put it here, it's post-order traversal, and I'm just doing in-order traversal, which is also fine. Doesn't matter. You're still going to traverse the entire thing. And I could do test case 2, and I will run it. And you can see that gives you the right answer. Oh, there's just a different range. This is, oh no, test case 2. Let me run that. Why isn't this? Oh, maybe my result here. Yeah, okay, so it's just saying this is the order that it's traversed. Okay. Thank you.